Hello everyone, this is Venugopal. I'm your mentor for geography. As part of this session, we will discuss on earthquakes. In our earlier sessions, we discussed about the interior of the earth. When we discussed about the interior of the earth, we understood that the earth is made up of materials of different densities. Now, how did we know that? The study of earthquakes helps us to understand the interior of the earth. Now, what is an earthquake? The earthquake is nothing but the motion that is caused by the conversion of potential energy into kinetic energy. So, when two landforms are colliding, eventually one of them gives up. So, there could be a subsidence, right? So, or there could be a breakage of the material there. So, that means there can be a release of energy at that point of time. So, when there is a release of energy at that point of time, the potential energy is converted into kinetic energy of motion. Now, this energy is dissipated. When this energy is dissipated, this travels through the earth. Now, when this particular activity happens inside the earth's crust and this release of energy is called as causes earthquakes. Now, how do we study these earthquakes? When we study these earthquakes, basically we need to understand a couple of important points. We have hypocenter or focus. We have another one called as epicenter. Hypocenter, we have epicenter. So why do we need to understand this? Because they will help us to understand which are the areas that would be affected because of that. Now, what is focus? Focus is the place inside the earth's crust where an earthquake originates. So earlier I was discussing about sudden release of energy when a plate subducts or when a plate ruptures and there is a release of energy, right? So the point where this actually happens inside the earth's crust, that is called as focus. It is also called as hypocenter. Focus. It is also called as hypocenter. Now, this is happening inside the earth's crust. The focus is within the earth's crust. Now, the point vertically above on the earth's crust is called as epicenter. This is epicenter. So, point vertically above. This is focus. This is epicenter. Vertically above. This is the epicenter. Now, there is one more top point which is called as antipode. What is antipode? Now, earth is in circular shape. Now, let us assume that this is focus. This is vertically above. This is called as epicenter. Right? Now, diametrically opposite point to the epicenter is called as antipode. The diametrically opposite point on the earth's surface to the epicenter is called as antipode. Now, what is its significance? Now, when we discuss further and we discuss about shadow regions of an earthquake waves, that is when we will understand what is an antipode. Okay? So, when the energy is released, right, it travels in the form of waves, right? So, which are called as seismic waves. These earthquake waves are called as seismic waves, right? And the stations which read these seismic waves are called as seismic stations. Now, when we measure earthquakes, we measure in two scales. One is Mercalli scale. The second one is Richter scale. Right? We measure in two scales. Mercalli scale measures the intensity of the earthquake, whereas Richter scale measures the magnitude of the earthquake. Richter scale measures the magnitude of the earthquake. So, when we normally indicate earthquake and we say, earthquake of Richter scale 3 or when we indicate, that means we need to understand whether it is Mercalli scale or whether it is Richter scale. Now when these waves of energy travel through Earth's layers, right, there could be waves of different frequencies generated, different amplitude generated. Now that is when we classify all the waves that are generated into different categories. Okay, but when they are traveling, right, their velocity, their amplitude, they all vary based on the density of the medium, the elasticity of the medium, and the wave type also. The wave type also impacts it, right? So the energy, the waves of energy travel through the earth layer, and their propagation velocity, the velocity which they travel, is determined by the density of the medium, the elasticity of the medium, and the type of the wave. Because earlier when we were discussing about the interior structure of the earth, we mentioned that there is a difference in the density from one layer to the other. From crust to mantle to core, there is an increase in the density, right? And when we say elasticity of the medium, we know that the earth's outer core is of liquid state. Now certain waves travel through the liquid medium and certain waves do not, right? And asthenosphere, when we discussed about asthenosphere we said it would be in plastic state. The upper part of the mantle that is in plastic state, we call it as asthenosphere. Now if it is in plastic state, that means the velocity of certain waves should change in plastic medium, because there is change of medium, there is a change of mechanical properties of the material also, right? And type of wave, if it is a transverse wave, if it is a longitudinal wave, that also affects the velocity of the wave. When I say transverse wave and longitudinal wave, we will discuss in detail on what is a transverse wave, what is a longitudinal wave. But before that, let's try to understand the different type of earthquake waves, right? Different type of waves that are considered as seismic waves. Primary distinction is body waves and surface waves. Okay, what are body waves? If I say this is earth, right? The waves that travel inside the earth's body are body waves. The waves that travel on surface of the earth are surface waves. Simple. Okay? Surface waves travel at earth's surface. Body waves travel through the surface of the earth. Okay? Now, which waves decay more slowly? Surface waves decay more slowly than body waves. Again, this is an important point because this could be one of the options in any preliminary question. Surface waves decay more slowly. That means they exist for longer periods and they are existing on the surface of the earth. Where do we have buildings, right? There are a lot of constructions on the surface of the earth. That means these surface waves, if they decay more slowly, that means they last longer. That means they can have a larger impact on the constructions, right? That means they might cause more damage. So that's why surface waves, when I say they decay more slowly, you have to infer it this way. They last longer and they cause more damage compared to body waves. So that means this is also responsible for the damage that it would induce. If the particle motion is more, that means more damage obviously. So particle motion is more in surface waves, hence cause more damage. Okay, two things. That means the surface waves decay more slowly, that means they last longer. The particle motion is more in the surface waves. So that means again, that is also one of the reasons that they cause the damage more. Okay. Now, which waves travel in 3 dimensions and which waves travel in 2 dimensions? Body waves travel in 3 dimensions. Now, these are all facts. These are facts. Each of them could be an option in your prelims question, right? Now, earlier when I was mentioning types of waves, I said longitudinal or transverse, right? Now, what are longitudinal waves? What are transverse waves? If you look at this, let's say a wave is traveling in this direction. The direction of motion of the wave is in this direction, right? This is called as a motion or the vibration of medium is parallel to the direction of the wave travel. Now, if you see, if this is the direction, the vibration of the particles is also in this direction. If you see a spring, let's say if I am fixing a spring on one particular point and I am compressing the spring and then I am actually releasing it. So, it oscillates in this direction, right? So, that is what they are trying to say. The vibration, right, or the propagation of the particles is in the direction of the wave itself. That is when they are called as longitudinal waves, parallel to the direction of the wave in which it travels, right? Now, displacement is either in the same direction or opposite direction, right? Here if you see, it's in the same direction, here it is in the opposite direction. So, the displacement of the medium, the movement in the medium is either in same direction or opposite direction. Now, you might get a question, why am I discussing longitudinal waves? Because if I have to understand which of these body waves or which of these surface waves are longitudinal or transverse waves, then I will be able to easily answer the questions. That's why we are going in detail on what are longitudinal waves. And in the next slide, we will discuss in detail on what are transverse waves. Okay? They produce compression and refraction. See here, they are producing a compression and there is a release, that is refraction. So, longitudinal waves are producing compression and refraction. Okay? Examples of longitudinal waves? P waves. Right? What are P waves? We will discuss. Okay? Sound waves is another example of longitudinal waves. So, to summarize, what are longitudinal waves? In longitudinal waves, the particle motion is in parallel to the direction of the propagation of the wave. In parallel. It could be either in the same direction or it could be in the opposite direction or in the same direction. Right? The particle motion. Right? And displacement of medium is either in the same direction or opposite direction. They produce compression and refraction. What are transverse waves? Oscillations are perpendicular to the wave's advancing direction. Suppose the wave is moving in this direction. You see this here? The wave is moving in this direction. And what is the direction of the oscillation? See here? Right? That means the particles are oscillating in perpendicular direction to the direction of the propagation of the wave. Right? So, displacement of the solid particles is in the perpendicular direction. Also, that means they are moved away from their relaxed positions. Right? So, these are called as, they are moved away from the relaxed positions. They are also called as shear waves. This is very important. Try to understand this. The displacement of these particles in the vertical direction or the perpendicular direction to the direction of the propagation of the wave calls a shear deformation. Hence, they are called as shear waves. Okay? So, transverse waves have another name. They are also called as shear waves because they cause a shear displacement. Now, fluids. When I am discussing about Earth's interior, I mentioned that the outer core is in liquid state. When we were discussing about the asthenosphere, we mentioned that it is in plastic state. Now, fluids cannot resist shear forces. Hence, propagation of transverse waves inside the bulk of fluids is not possible. That means, if there is a transverse wave and it is passing through a liquid medium, it cannot propagate further. It dies off there. Okay? Now, this is very interesting and this is important also. Now, let's discuss about body waves. We discussed about longitudinal and transverse waves, which are categories of waves. But when we discuss about seismic waves, we talked about seismic waves have two different broad categories, which are body waves and surface waves. In the body waves, there are two different kinds further, which are called as primary waves and secondary waves. Two different types of body waves, primary and secondary. Primary waves, why are they called primary? Because they reach the seismic station first. That means they have the highest velocity. Remember that. If they are reaching the seismic station first, it means they have the highest velocity. Since they are reaching first, that's why we call them as primary waves. Okay? And primary waves are longitudinal in nature. We discussed, right? Longitudinal means what? The motion of the particles, the displacement of the medium is in same direction as the propagation of the wave itself. Again, I am repeating it. When I say longitudinal, that means the displacement of the medium is either in the same direction or in the opposite direction to the propagation of the wave. That means the direction of the displacement of the medium is also parallel to the direction of the propagation of the wave. If you look at this, right, the direction of movement of the medium is either this direction or this direction, right? Again, when we discussed about longitudinal waves, we also mentioned that there would be a compression and refraction. Since P waves, which are primary waves or longitudinal waves, they also induce compression as well as refraction in the same direction as that of the propagation, right? That means in the direction parallel to that, right? Now, they travel through any kind of material. When we were discussing about transverse waves, we mentioned that since they cannot travel through liquids, that means that wave would die off there. But when we discussed about longitudinal waves, we didn't mention anything of that sort. So longitudinal waves travel through all mediums. Hence, the primary waves, which are of longitudinal in nature, they travel through all the mediums. That means they will travel through the crust, they will travel through the mantle, they will travel through the liquid outer core, solid inner core, and also the upper part of the mantle, which is in plastic state, that is asthenosphere also. Okay? Now, what are secondary waves? Secondary waves are actually denoted by S. S waves are secondary waves. Okay? They are of transverse nature. Transverse means, again we discussed one thing, there is a shear displacement. So any transverse waves are called as shear waves also. So S waves are also transverse waves. Hence they are also shear waves. They are transverse in nature. So when we discussed about transverse in nature, when we discussed about propagation of the particles or the displacement in the directions parallel to the propagation of the wave. See here, the displacement here, if this is the direction of propagation of the wave, the displacement of particles is in a direction perpendicular to the propagation of the wave, right? These are S waves, which are also called as secondary waves. So when we discussed about body waves, we discussed about primary waves, we discussed about secondary waves, right? Again the same thing, if I am holding a rope and oscillating it, you see this, the direction is perpendicular. The movement of the particles, the movement of the medium is perpendicular to the direction of the propagation of the wave. Clear? Now, we discussed about body waves. Now let's discuss about surface waves in detail. Surface waves travel on surface of the earth. Clear? There are two kinds of surface waves. They are love waves and the second one is Rayleigh waves. Okay? Now, earlier when we were discussing about the seismic waves, when we classified them as body waves and surface waves, we mentioned that the surface waves take longer to decay. First point, we discussed that they take longer to decay. Second, surface waves also have more particle motion. Particle motion is more. Particle motion is also more. These are surface waves. Hence they cause more damage. Now, within surface waves, there are two kinds of waves. One is love waves and the second one is Rayleigh waves. Okay. Now, this is an example of the movement of the particles when a love wave is progressing. This is an example of the particle movement when a Rayleigh wave is progressing. Right? If you see in a love wave, the particles are moving away from the direction of the propagation of the wave. You see this? That means here they are moving in this direction. If you see, here they are moving in this direction. 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 So what? What do we observe here? Suppose I crack a whip. The whip moves like this, right? So this is moving like a whip on the surface. If the wave is propagating like a whip on the surface, it would cause more damage to the buildings. Okay? So love waves would cause more damage to the buildings. They have a whiplashing effect. What about Rayleigh waves? In Rayleigh waves, there is a three-dimensional movement of the particles. You see here? There is a three-dimensional movement of the particles. Compared to love waves, they cause less damage. Now, let's discuss some more facts about Rayleigh waves. Okay? Since when I mentioned Rayleigh waves have three-dimensional, right? I mean like in all 360 degrees. They are longitudinal as well as transverse. That means the particles either oscillate in this direction also, they can oscillate in this direction also, right? So the Rayleigh waves are both longitudinal and transverse motions, right? They travel in parallel to the direction of propagation. Okay? In parallel to the direction of the propagation, right? During earthquakes, the low frequency Rayleigh waves which are generated are used to study the Earth's interiors. Okay, if anyone asks, I mean all the waves are used to study the Earth's interiors, but more importantly, low frequency Rayleigh waves are used in seismology to characterize the Earth's interior. Okay, now again, they have commercial use also, right? So in geotechnical engineering, they are used for oil deposits. To identify oil deposits also, these surface waves called Rayleigh waves are used. Now, when a tsunami occurs, right, and the animals seek higher ground. So they have observed that, I mean there is a hypothesis again, it's not completely proved, but again they say that these Rayleigh waves serve as a warning to these animals that an earthquake is about to happen. What are love waves? Again, in love waves, let's say the wave is propagating in this direction, either this way or this way. You see here, if this is how a wave is propagating, the particle motion is either in this direction or in this direction. That means it is actually in perpendicular to the direction of the propagation of the wave on the surface. But again, when I draw a diagram, again, this is what earlier I was drawing, right? Whiplash effect, right? That's why they are more destructive. More destructive. Right? They travel in a horizontal line perpendicular to the direction of propagation. So when a wave is traveling in a direction that is perpendicular, when a particle motion is perpendicular to the direction of propagation, that means it is a transverse wave. Okay? It's a transverse wave. The strength of the waves decrease exponentially with the depth of an earthquake. The love waves, right? The strength of the waves decrease exponentially with the depth of the earthquake, right? And they decay more slowly, which we discussed earlier, right? Surface waves decay more slowly. Love wave is a surface wave. Okay? In this diagram, we are actually depicting all the four. Primary waves and secondary waves, which are body waves. Then we have surface waves, which are Rayleigh and love waves. Primary waves both have compression and refraction. If I have to consolidate, primary waves longitudinal, parallel to the direction of propagation. The particle motion is parallel to the direction of the propagation of the wave. There is compression and refraction, which we saw here. Compression, refraction, compression. Right? Now when we come to the S waves, they are transverse in nature. They are also called as transverse means shear waves. Particle motion is perpendicular, right? In Rayleigh waves, the particle motion is both longitudinal as well as transverse. Again, the movement is in the direction of the propagation of the wave. In love wave, again this is perpendicular to the direction of the propagation of the wave. In love waves, perpendicular. That means again they are transverse. And which causes more damage? Love waves cause more damage. Which reaches first? Primary waves reach first. Which take longer to decay? Both Rayleigh wave and love waves take longer to decay because they are surface waves. Now, velocity versus depth. What is this? Because when we were discussing about the velocity, we said that density of the material, mechanical state of the material, density, mechanical, type of wave. We discussed about all three. Density of the medium, mechanical properties of the medium, type of the wave. All three would determine the velocity of a seismic wave. Now, crust is in solid state. The upper part of the mantle is in semi-plastic state, right? Then we have rest of the mantle in solid state, but the increase in density is very gradual. Then we have outer core, which is density is high, but is it in liquid state? Then you have inner core, right? Inner core. Now, if I have to understand the velocity, we need to understand how the longitudinal waves and transverse wave propagate. Now, we discussed that a transverse wave does not pass through liquid. That means S waves, secondary waves, which are transverse in nature, they would not propagate through the liquid medium, which is the outer core. That means their velocity will completely become zero there. Their velocity in the outer core is completely zero. Okay? Now, if you see how the velocity is changing, you see here, this is increase in velocity, this is velocity, this is depth, right? If you see a S wave, the S wave's velocity gradually increases, right? Or if you see, right, and in outer core, it is completely gone because these are transverse, right? Now, why do I need to understand that velocity chart? Because there is something called a shadow zone. Shadow zone. What is shadow zone? Shadow zone is, let's say earthquake occurs on one side of the hemisphere. Okay. Let's say earthquake occurs in the northeastern hemisphere. Right. Should I see the impact in the northwestern hemisphere or southwestern hemisphere? How would I know that? That means, let's say if this is earth, we were discussing about epicenter and antipode. If this is epicenter, what they noticed is that at the antipode they were not detecting all the waves. This is focus or hypocenter, right? So that means something is happening within the inside, the earth's inside, right? Now, earlier when we were discussing the velocity chart also, and when we were discussing about surface waves and body waves, we discussed about transverse waves. Transverse waves are shear waves, right? And they do not propagate through liquid medium. If that's the case, let us say S waves. So all the S waves, when they reach the outer core, like this here, right? See here, they are reaching the outer core. This is in liquid state. Anything that reaches the liquid outer core dies off. So that means only those which are actually traveling tangential to the outer core. Tangential to the outer core. Right? You see here? So that means the S waves cannot be seen in a region between 103 degrees and 103 degrees in both directions. So this is all the surface on the earth, right, is shadow region for S waves, not for P waves, for S waves, because S waves do not travel through the liquid outer core. What about P wave? When we were discussing about P waves, we mentioned that they are longitudinal waves and they will travel through all mediums. But you should understand something called as refraction. What is refraction? Refraction is, in your 8th standard or 9th standard, you would have understood about light. Let's say this is a dense medium. Okay? Now, if a light is hitting at 100%, if a light is hitting like this, right, and it is traveling immediately in the same opposite direction, right, it is reflected. If it is a mirror, it is reflected, right? This is a reflection. Now there is something called as refraction. What is refraction? Suppose if any wave is traveling through mediums of different densities. This is medium of density D1. There is a separation, right? This separation is to indicate difference in densities. This is D2. Okay. So wave which is traveling from D1 to D2 slightly refracts. That means there is a slight change in the direction. This is called as refraction. Okay. Now the P waves are traveling through materials of different densities. Crust, mantle, core. We discussed, in crust the density increases more, right? There is a steep increase of density with depth in crust. In mantle there is a gradual increase of density, right? In core is of the highest density, right? So that means if there is a variation in the density, that means when the wave is propagating, it is encountering materials of different density as it is traveling through each of these layers. That means the wave continuously gets refracted. So if it is continuously getting refracted, a wave which started here eventually travels in this direction, right? Similarly here also, it travels in this direction, right? Because they travel in 3-dimensional. These body waves travel in 3 dimensions. So it is getting refracted here, like this, like this. So when it encounters a medium of different density, see here, outer core, liquid state, it is refracted this way. Right, instead of going this way, it is refracting in this direction. Again, see here, this further refraction. So if you observe, there is a continuous refraction when it is propagating from one medium to the other. In this case, you see here, there is a refraction here, there is a further refraction here, there is a further refraction here. See, it's not going in one straight line, it's refracting. Now, because of these refractions, there is a shadow layer. That means certain areas of earth would not receive a primary wave also, which is here, right? And again here also. See, if you see, it is between 103 degrees and 150 degrees on both sides. 103 and 150 on both sides for primary waves. What about secondary waves? Secondary waves is between 103 and 103 completely, right? So this entire area is not going to receive the secondary waves. For primary waves, it is this shadow regions. Okay? Because primary waves are longitudinal. Secondary waves are transverse. They will not travel through the liquid outer core. Now, let's discuss a few prelims questions, model questions. Which of the following waves reach the earthquake station first? Now, whether it is primary, secondary, Love and Rayleigh waves. When we were discussing about P waves are nothing but primary waves, right? They are called as primary because of the region that they are discovered first, they reach first. Hence, they are called as primary waves. Since they reach first, they are called as primary waves. That itself answers the question that primary waves. Now, Which of the following waves are considered as body waves? Now we discussed about two things. Body waves. We also discussed about surface waves. Body waves travel through the interior of the earth. Surface waves travel on the surface of the earth. Right? Now, under body waves we have two, which is P waves, which are primary, S waves, which are secondary. Under surface waves we have Rayleigh waves and love waves. Right? Now, the question is, which of the following are considered as body waves? It should be both P waves and S waves, primary and secondary. Right? Which of the following waves causes more damage? Right? Which of the following waves causes more damage? We discussed about this. Surface waves. We discussed, when we were discussing surface waves, we discussed two properties. Take longer to decay. Second, particle motion is more. That means what? Particle motion is more. That means what? That means surface waves are actually, they cause more damage compared to body waves. Now again, within surface waves which cause more damage? Again, for that also we discussed that love waves have a, if this is the propagation, love waves actually travel perpendicular to that propagation of the wave. That is a whiplash effect we discussed. That means love waves are more harmful. They cause more damage compared to any other wave. They are love waves. Clear? Okay. As part of this session, we discussed classification of earthquakes. Okay. Now, we'll continue with our next session with another topic.